number 16, we have these two functions. F of x is 1 over 3 minus x squared, and g of x is x divided by 3 minus x squared, all of that squared. So first part is that we have to find a power series for f of x with center c is equal to 0 using geometric series expansion. And then we're going to try to do the same for g of x using our answer to the previous part. Okay, so how do we tackle this? Well, we want to, this looks kind of like the known series for 1 over 1 minus z is the sum of n from 0 to infinity of z to the n. So I want to manipulate this to look like this. How do I do that? Well, we shouldn't be concerned with x squared here. I could have put an x instead of z here. I'm going to substitute in for this later, so using different letters will make the substitution a little bit more clear. The big thing that we have to worry about right now is that 3 right there. That absolutely has to be a 1. So we're going to have to factor things out and manipulate it until that 3 becomes a 1 here. So the first thing we're going to do is factor a 3 out from the denominator, and we end up with 1/3 times 1 minus x squared divided by 3. So we multiply this 3 back through, we end up with 3 minus x squared, right where we started. So this looks a little bit more complicated, but it allows us to use this nice sum over here. So we're going to substitute in, what are we going to substitute in? X squared minus 3, and it's going to replace z here, and it's going to replace z here, and all of this put together is going to give us our Taylor series as 1/3, chilling out in front, times the sum from n from 0 to infinity of, we replace z with x squared over 3 to the n. Now if we rewrite this just a smidge, so that's x to the 2n divided by 3 to the n. 3 to the n in the denominator. We have an extra factor of 3 in the denominator over here. We can move that inside. Oops. Move that inside so it goes away. X to the 2n divided by 3 to the n plus 1. Okay, so part A is done. Here's our answer to part A, the sum of n from 0 to infinity of x to the 2n divided by 3n plus 1. Now we're supposed to come up with a series expansion for g of x, and we are told to do it using the series expansion for f of x that we just came up with here. So what's the connection between these two series? Well, note here, if you look at it, it's like this denominator, when we square this, we get 3 minus x squared. The denominator here is the square of the denominator over here. And so this to me feels kind of like, almost maybe like a quotient rule is happening here. Taking the derivative here to get this. Let's see if something like that is happening. Let's actually sit down and calculate what is f prime of x from scratch. So the derivative of this from scratch, if I use the quotient rule, 3 minus x squared squared, and then low times the derivative of high, which is 0, minus high, which is 1, times the derivative of the downstairs is minus 2x. So this becomes 2x divided by 3 minus x squared squared. In other words, this is exactly twice what g of x is. So g of x is equal to half of the derivative of f of x. Okay, so what good does that do with power series? Now let me bring back this theorem here. Term-by-term differentiation and integration. In this case, we're looking at term-by-term differentiation. If we have a power series here, we can just differentiate it term by term to end up with the derivative here of f of x is just differentiate this term by term. So x minus c, bring down a factor of n, reduce that by n minus 1. We just differentiate each term one at a time. Okay, so we know that f of x, let me recopy this. Earlier we had it's the sum from n from 0 to infinity of x to the 2n divided by 3 to the n plus 1. When we take the derivative here, what happens? We bring down the exponent, is 2n, and we subtract 1 from it, x to the 2n minus 1. That 3 to the n minus 1, we're taking the derivative with respect to x, so that's not affecting n's. So this is what things look like here. And this is equal to, as we said before, 2 times g of x. So if we want our final answer is g of x, is just going to be divide this by 2. And I can just cancel out those 2's there. By the way, I'm going to start the sum. At n is equal to 1, because when n is equal to 0, the term is going to be 0 there. So the final answer I'm going to give is n times x to the 2n minus 1 divided by 3 to the n minus 1. Okay, so what's the quick summary here? What happened in this problem? Number 1, using pattern matching, pattern recognition here to quickly come up with the Taylor series for 1 over 3 minus x squared, and then applying term by term differentiation to come up with the power series for g of x.